Welcome to Physics with Joe. Today's video is going to be all about introducing forces and some of the common forces you'll see in our study of dynamics using Newton's second law. I'll first give a quick definition of what forces are and some of the characteristics of forces. Then for each of the 8 common forces that you'll see, I'll define the force, give the notation that we're going to use in class, and then finally talk about the direction that the force acts. So without further ado, let's jump right into it. Let's start with a simple question. What is a force? Well, at its most basic, a force is really just a push or pull that's being exerted on an object. The thing that's exerting the force we call the agent. So anytime there's a force or forces on an object, you should be able to name what the agent for each force is. For example, the force of gravity on an object. The agent would be the earth pulling down on the object. Or if I have, say, a box sliding across a rough floor, the friction on the box is actually being exerted by the floor. So anytime there's a force, you should be able to name what is producing that force. We call that the agent. Forces can generally be classified into one of 2 types, either contact forces or long-range forces. In a contact force, the agent is actually physically touching the object. So for example, I may push a box. I'm actually contacting the box. On the other hand, something like gravity, the earth is not making physical contact with the object. We call that a long-range force. Another example might be me picking up a piece of iron using a magnet. The magnet does not have to be in physical contact with the piece of iron to exert a force on it. And then finally, forces are vectors. And just like any vector, they have both a magnitude and a direction. For a force, the magnitude is just the strength of the force in newtons, and then the direction will be the direction that that force is acting. So let's take a look at some of the different forces that we're going to see in our study of dynamics. There are 8 common forces that you'll see all the time when doing problems using Newton's second law. Those 8 forces are listed in the table next to me with the name of each force as well as the notation that we're going to use in class. Before I jump into each force, let me just say that for a generic force, the notation we're just going to use is F, often with some kind of subscript like F1, F2, F3, and so on. So for example, if you had a problem that stated a 25 kilogram box is sitting on a frictionless surface, there are 2 forces acting on the box. A 195 Newton force pulling to the right and a 145 Newton force pulling at an angle of 32 degrees above the negative x-axis. So if it's just a generic force, I would just label those forces F1, F2, or some kind of notation that makes it clear which force is which. Let's start with the force of gravity. Gravity is the attractive force that exists between any 2 objects with mass. Technically, you're exerting a gravitational force on every single object in the universe that has mass, and every object with mass is exerting a gravitational force on you. However, gravity is such a weak force that we can generally ignore it unless we're talking about the gravitational force from a planet or a moon or something massive like that. So when you hear the force of gravity, we're really referring to the force of gravity from the Earth on an object, which is also known as the object's weight. So weight is just another name for the force of gravity from a planet, or in this case, from the Earth. In this class, we're going to use W to represent the force of gravity on an object. W just short for weight, although in some books you may see F with a G subscript. The force of gravity from the Earth is always straight down towards the center of the planet. The spring force is the force exerted by a stretched or compressed spring. We're going to use the notation F with an SP subscript to represent the spring force, and the direction of the spring force is always in the opposite direction the spring is stretched or compressed. So for example, if a spring is stretched to the right, it exerts a pulling force to the left. Or on the other hand, if a spring is compressed to the left, it exerts a pushing force to the right. The force is always in the opposite direction the spring is stretched or compressed. Tension is just the force exerted by a taut rope or string. We're going to use the symbol T for tension, And the direction of tension is always along the line of the string or rope in the direction of pulling. A rope or string cannot exert a pushing force. It's always a pulling force along the direction of the rope or string. The normal force is the perpendicular support force exerted on an object by a surface in contact with the object. We're going to use the symbol N to represent the normal force, and the direction of the normal force is always perpendicular to the surface. So for example, if I have a book sitting on a table, the table exerts an upward force which is perpendicular to the surface of the table. Or if I have a frog sitting on an inclined plane, the plane is exerting a normal force perpendicular to its surface on the frog. Static friction is the force of friction that acts between two objects that are at rest relative to each other. We're going to use F with an S subscript to represent static friction, and the direction is always in the opposite direction the object would move if there was no friction. So for example, if somebody is pushing a heavy box on a rough surface and it does not move, it's the force of static friction which is preventing the movement, and it's acting in the opposite direction the man is pushing because it would move in that direction if there was no friction. Now, if the man pushes hard enough, then the box will start moving, and it's no longer static friction, it's now kinetic friction. Kinetic friction is the force of friction between two objects that are in motion relative to each other. We're going to use the symbol F with a K subscript to represent kinetic friction, and the direction of kinetic friction is always in the opposite direction of motion. So if a box or book is sliding to the right across a rough surface, the force of kinetic friction would be acting to the left. It's always in the exact opposite direction of the velocity. Drag is just another name for the force of friction from a fluid on an object. And in physics, a fluid can either be a liquid or a gas. The drag force is usually represented with either F with drag subscript or capital D. In our class, we're going to use capital D to represent drag. And 99 times out of 100, we're using drag to refer to air resistance. And the direction of drag is always in the exact opposite direction the object is moving. So drag is always in the opposite direction of the object's velocity. Thrust is the force that occurs when a jet or rocket engine expels gas molecules at high speed. To represent thrust, we're going to use the symbol F with thrust subscript. The direction of thrust is always in the opposite direction that the gas molecules are expelled. And it's really just a result of Newton's third law. For example, if the rocket expels the gas molecules downward, then the gas molecules exert an upward force on the rocket called the thrust. Well, that is it for the short catalog of some of the forces you're going to see when we start doing dynamics problems using Newton's second law. Thank you so much for joining me for Physics with Joe. I hope you tune in next time when we're going to be talking about something fascinating. So until then, my name is Joe McCullough, and I still need a catchphrase.